Example 2, a random sample of 100 people shows that 25 are left-handed. Form a 95% confidence interval for the true proportion of left-handers. So first step, you need to know which situation you're in. And how we know which situation we're in is because we're given two numbers. We're given 25 and 100. So we know that we need to divide these two numbers to get a percentage. So 25 divided by 100, that gives you 0.25. This is a percent. So because we know this is percent, so therefore we know that this is population proportions. So therefore we're going to use the Z distributions. And that's the first step, understanding which situation you're in. Once we know that we're in a situation of population proportion, our second step is drawing the confidence interval. So in this diagram here, we have a normal distribution bell curve. Then we draw the mean. Your mean is your 0.25. And then because we're looking for 95% confidence interval, that means we're looking for x1 and x2. And then between x1 and x2, there's 95% area here. That's what we're looking for, the 95% confidence interval. And because this is symmetric, that means our alpha is 5%. So we take the 100% minus the 95. That gives you the alpha. Alpha is 5%. So alpha divided by 2 will give you the area on each side, which is your 0.025. That's your alpha over 2 on each side. So once we understand the diagram, we know that we're looking for x1 and x2. Our next step is to use the formula. And since we know that we're in the population proportion situation, we know that we're dealing with Z distributions. So therefore, we can basically use norm.inv. We can basically use this single formula to help us get x1 and x2 directly. So we don't have to use this algebra here. The reason we don't need to use this algebra here is because Excel has a single formula, which is norm.inv, which we learned before. And this single formula can directly help us get x1 and x2. So for x1, we have equal norm.inv. It will ask you for the probability. So probability is the probability to the left of x1. The probability to the left of x1 is your 0.025. That's the probability to the left of x1. For x2, the same idea, equal norm.inv. And for the probability, that probability is the probability to the left of x2, which is the 97.5%. And how we get the 97.5% is we take the 95% and then we add the 2.5%. So those two numbers are the probability to the left of x2. So that's how we get the 97.5%. And then the mean are the same for x1 and x2. We're going to use the mean of 0.25. That's your proportions. And for your standard error or your adjusted standard deviations, the reason we're using standard error is because we're dealing with sample. Whenever we're dealing with sample, we have to use the standard error or the adjusted standard deviations. And the formula for standard error for population proportion is basically your p times 1 minus p divided by n and then square root. So p is 0.25 times 1 minus 0.25 divided by 100 and then you square root. You're going to get 0.0433 and that's your standard error. That's your adjusted standard deviation that we're going to use into the formula. So once we have these three variables, then we can plug it into Excel equal norm.inv to get x1 and x2. And you're going to get 0.1651 and you're going to get 0.3349. And I won't show you how to do that in Excel. You should know how to do that so you can do that on your own. And that's example 2.